Welcome to Let's Roger That, everybody. Today we're going to have a little discussion on how contactors work. Contactors are usually used in applications where you want to power a motor and you want to use it as a safety switch in essence. So let's go to the board and let's review how that works. Now, as an add-on to this introduction, I just want to mention that if you're going to watch my video on VFDs, which is to follow, I strongly suggest that you watch this video first and to get a good understanding of contactors and emergency switches and start switches. And then we can proceed to the VFD video without actually trying to explain while we're installing wires in a little tiny box. Now, something I want to mention before I get started is that I have absolutely fantastic viewers, so thank you to all of you. But specifically the ones that provide me with comment and input and sometimes steer me away from doing something really stupid or something that is not quite 100%. So let's go look at the box right now, and I've actually had to make modifications just to ensure some safety. Specifically towards the safety aspect is that you want to make sure that you can't really activate this, especially when you got a whole bunch of stop switches in place. Previously, what I had done is I had brought in my main power, where the heck here, right here. So previously I brought in my main power and had it brought into A2 right up here, and then had another branch going to my E-stop. Now it worked. Everything worked fine, except that should I have pressed on the contactor, it would actually have sent power to my VFD, etc. So you don't want that to happen, and therefore I made the change. So all that took is taking the power, sending it to the switches first, and then when it comes back right here to the normally open, unless the switches are active, nothing goes to A2. All right, so once the circuit is closed, goes to A2, and the jumper sends it to L3, and now my machines work. So thanks, guys, appreciate that very much. Now let's proceed to how contactors work. So let's start by saying that a contactor, which is basically a box, right, has a coil in it. So that's the first part, right? And I'm going to draw the coil this way. It's not its correct drawing in electrical terms, but that's how I'm going to draw it, okay? Well, let's draw it into two separate parts. The second part is we have some contacts, and those are, in my particular case, they're normally open, which means nothing can go through, all right? And these contacts is what's going to eventually let us send voltage to our device. And the third portion of what a contactor does, it can either have normally open circuit or normally closed. Depends, you can either have it with both or just with one. I chose one. All right? Okay, let's continue. Okay, so this is where we are currently. Now, I'm just going to refer to this here as external controls. All right? Why am I calling it that? Well, because we're going to, you know, when you use a contactor, you're trying to control machinery. You want to have like emergency stops. You might want to have a start switch, and etc. All right? So, but these would be the biggest ones. Now, here, where we have the circuitry that allows power to go through to whatever, but let's, in this case, we're talking a motor, right? Say for example, a normal AC motor, right? It's got live and neutral. Okay, great. So we can forget about this for now then, because we only have two things to go through. So on a contactor, the input is listed as L1 and then L2, etc. And then the outputs are noted as T1, T2, etc. All right? So this is where at some point we'll need to send power through this to get to the motor. But remember, these contacts are open. So there's nothing that can go through unless this coil here, our first circuit, is activated or energized, shall we call it, right? Now on a contactor, you have terminals called A1 and A2. And say for example, we'll get our plug here. Let's just for now call it 115 volts, okay? So on North American 115 volts, there's a live, neutral, and then of course a ground, right? And so unless these two come in here and energize this coil, the circuit does not close. But once they are there, then all of a sudden these close here, right? But if of course there's nothing, then nothing will go through. Of course we'll have to get to the part of how do we send power to these two circuits. But this is how this works, okay? Coil is energized with a live, neutral. Okay, so we got power going through here, 115 volts, and then once the neutral gets contact in here, it energizes the coil and it closes these circuits. For now, that's what we need to know. So let's proceed to the next part. Now a contactor in real life looks like this. Now the brand that I purchased has the A1 at the back and A2. The L1, 2, 3 terminals are at the front, and at the bottom you got the T1, 2, 3s. And then you also have this one, right? This one has normally open contact here at the top and bottom, and they're named 13 and 14. And the other thing that's there is a manual switch to activate your contact. Okay, so if you don't have switches and you just want to test whether your stuff is correctly connected, you can actually manually activate the coil. All right. Okay, I'd love to have different colors here, but my dog ate my homework. So I don't have different colors anymore. Anyhow, so this is a representation of the contactor I just showed you. It's got the A1, which represents one side of the coil, and A2, which represents the other side. And without these two connected and having voltage going through in according to whatever the voltage requirement of your contactor is, then this thing remains open and the coil does not get energized. So let's just say that first of all that I'm going through this because I'm going to install a VFD, right? So that's why I want to go through the basics of how this works and how I used it myself. So essentially you can have your outlet like we did before, right? And now we need to start connecting all this stuff. But because we're going to add a whole bunch of stuff later, let's add them into the picture now, okay? So we're going to have a VFD, and that VFD is going to be used to convert one-phase power, which is what comes out on most people's outlets, to three-phase, which means there's 3 wires going to my motor, which is a 3-phase motor. Now my motor is 230 volts. Okay, so that's what we're going to start with. I've got a contactor that activates and can let through 230 volts, and that also activates on 230 volts. And my VFD, of course, is appropriate for those as well. And that's very important. You need to pick what you need. Okay, now for the sake of clarity, I'm going to remove L3 and T3 from here. I just want to keep things nice and simple. The contactor is going to let through whatever we put through it, right? And it's the VFD that's going to convert from one phase to three phase, T1, T2, T3. So let's move on from that for a moment. All right, so you see I've added the stop switch and of course a start switch, and I've indicated the outlet here. So let's start from the beginning. I've got a 230 volt outlet. Now a 230 volt outlet has a ground. This is what it looks like. And it has two live wires, each of them carrying 120 volts or 115, okay? So we've got, they're live, both of them are live. There's no neutrals in this case. But honestly, don't let that fool you. It's not a problem. Everything's going to get connected exactly the same way. So essentially, we're going to take this one and we want it connected to A1. Okay? That's going to be here, and that's going to, now we have one side that has power. But we don't want to send that here now because, quite frankly, we don't want this to be energized and close all these circuits. We want to go through our emergency stop and our start switch because that's how we're going to control our contactor's ability to send power to the VFD. So what we're going to do here is we want our emergency stop and our start switch to control the flow of current, and therefore we're going to take this other leg and we're going to send it right here to our e-stop, right? An e-stop is a normally closed circuit. You can get them that have both, but essentially that's what they are. So unless we activate the emergency stop, whatever we're putting through it is going to go through. All right. Now we want to connect this to our start switch. So we're going to do that. Now we're connected. Great. And we want the other side of our start switch to go and activate this normally open and normally circuit here, which is part of our contactor, right? 13 and 14. So that we're going to use this to use our external controls. So these will be our safety switches. They will activate these, and then when that circuit is closed, we'll get that to send power to A2, and then we'll go up to here and then we'll continue with the lesson. All right, so that's what we're going to do. Now if you can imagine this for a second, everything that flows through here goes in that direction, right? It goes into the e-stop, etc. The e-stop, we can get it to stop and open the circuit, or if it's not activated, then everything flows through. Now, as it goes to the start switch is a normally open circuit. So unless you push the button, this does not close, it's open, right? So it's coming through here, and say we press on the start button, now all of a sudden, we're going to have power going from the start switch, all the way to this normally open here, all right? So like that. But unless both of these things are activated, it's not going to stay on, all right? So let's say this activates, we press the stop button, all of a sudden we've got a closed contact here, and we got power going here. Well, that's lovely, but that still doesn't send power through the whole thing. So essentially, what we have to do is add another line in here somewhere, right? So we'll take one from the middle, between the e-stop and the start switch, and that thing is going to go to the other side of the normally open circuit on the contactor, number 14. Now, we're going to take a loop out of here. So basically we're going to take another wire as a jumper. This is, we're going over top, all right, or around it. And then we're going to connect that to A2. All right, so let's do a quick recap right away. We've got a live going to A1, and we've got a live going to our emergency stop. Emergency stop is deactivated, therefore letting current go through. It goes to the start switch. The start switch, okay, we're activating it. So we're sending voltage or current to one side of the normally open circuit of the contactor. This side here, once this happens, it goes to here. But unless the start switch is what's called latched, completely closed, then nothing goes here, right? But when we do start this, all of a sudden, this contact is made. So now we've got voltage going through here, right? And by the way, we've just added a jumper that goes through here to our A2. So now we've got voltage coming through this whole contact. It's this normally open contact, and because it's latched, it's sending voltage to A2, which closes the coil. When the coil is closed, all of a sudden these circuits here actually can let through voltage as well. And that's where we're going next. Okay, so I've just decluttered the whole board here just to make things easy to see. And by the way, remember there's 3 terminals here. I'm only using 2 just to make things clear. I only needed 2, and most of you will as well if you're just doing this kind of thing. All right, so we've got our power going to A1 and our power going to A2. How do we get power to L1 and L2? Well, first of all, we're going to take a little jumper cable here when we first connect this A1, right? And we're going to connect A1 to L1. So there'll be 120 volts going to here, 115, whatever, right? Now, A2 needs to provide power to L2. So when we wire things up, we're going to take a little jumper and a cable, and we're going to send to L2. L2 is not going to get anything unless all of this is active, right? So now that the coil is energized and we've got power going to L2 and L1, essentially we've got power going through here to our 2 outputs, right? Great. So now our contactor is doing its job. It's letting the voltage go through, but it needs to go somewhere. So now we're going to take and put our VFD over here just because it's easier for on the board. And the VFD as an L1, 2, and 3. So only use 2, but it converts from 1 phase to 3 phase. Remember, 1, 2, 3. So now we're going to have 3 outputs: T1, T2, T3. So we're going to take these. They're going to connect here. And then when our VFD turns on, we turn it on either manually, or in my case, I'm using the e-stop and start switch to fire all of this stuff at the same time. So, but you can start it manually, of course. So now your VFD is on, and you've got your three-phase power, and we're going to send it to our motor. Our motor, remember, is 230 volts, three-phase. So it needs these three lines. 1, 2, and 3. And of course, it has a ground, right? Okay, and voila. That's it. We're powering our VFD. And we're using an e-stop switch and a start switch. So that's pretty simple. This is the nice, safe way of doing it. Previously, I had mistakenly sent my A2 directly, or my second live to A2, and then L2 jump third like this. It worked, but it's not the right way to do it, right? You shouldn't have a direct connection on A2 right away, because if you press the button, the manual switch to activate the coil, then you'll have power going through, and you know, bad things can happen. So rather, you want to minimize the amount of potential for injury, of course, right? Or fire or whatever. So this is how I wired my machine. All right. So I've got, let's review, our input voltage, 230 volts with live on both sides. One side goes directly to A1 with a jumper cable that connects it to L1. Our other live wire goes to our e-stop switch, which sends it to the start switch. And then from there goes to number 13, which is a normally open contact on the contactor. Then you connect a wire in between the two, and you send that to number 14, the other side of the normally open contact. Now, this is not closed yet, right? And then after that, we take this and we put another jumper cable between 14 and A2. So now, all this is working. We've got power going to A2, which closes the coil, and we're adding another little jumper to L2. So now we've got power going to L1 and L2. The coil is activated, and all the circuits are closed, and the power is flowing to our VFD. It's going to L1. This VFD is also 230 volts. Geez, I'm terrible at this. And it's rated exactly for this motor, right? From one phase to three phase. So basically, guys, that's how a contactor works. And this is how I use the contactor, the E-switch, the start switch to power my VFD and my motor that is on my milling machine. So the next episode, we're going to actually install the VFD, convert my machine completely. It's a one-phase 230 volts, and I'm going to put a new motor in there, add a VFD, e-stop, start switch, all that stuff, and I'll show you how I installed all that stuff. So thank you to my viewers who have been so nice to me and helpful. Also, please like and subscribe and shoot me a comment. I always love to hear from you. Take care. Bye-bye.